the directions for this problem. We want to sketch the angle and then find the reference angle. So to go through and to sketch our angle, we're going to start with our angle in standard position. That means we want to think of it kind of like a spinner, and the initial side where we're going to start with our spinner, that's on the positive x-axis. And then we take a look at our angle, and our angle is positive. If you're spinning in a positive direction, that is counterclockwise. And we want to go 150 degrees. Well, right here, as we're starting, that's where 0 degrees would be. And if we rotate up to the top, that would be a right angle. So a positive 90 degrees would be at the top. And 180 degrees would be halfway around. If we go another 90 degrees down here at the bottom, that would be 270 degrees. And if we went all the way around back to where we started, that would be a full circle. That would be 360 degrees. So if we're going to sketch this angle, we'll go around counterclockwise until we go 150 degrees. That's past 90, but not as far as 180, so it would be somewhere right around here. That's about where 150 degrees would be for our angle. So that's the first part, sketch the angle. Then we're supposed to find the reference angle. The reference angle, that is the angle between our terminal side where our spinner stopped and the nearest x-axis, which for us would be this x-axis over on the left side here. So we're trying to calculate this angle right here between the terminal side of our angle and then our x-axis. And if we have written in the angle and then also these values that we have at each one of the axes, that's pretty easy for us to see what that's going to be. We're trying to see how big the angle is between 150 and 180 degrees. When you list out a reference angle, we always do a positive angle for that, and it will always end up being an angle that is between 0 and 90 degrees. So our reference angle on this one, we just need to go through and subtract those values. So 180 degrees minus 150 degrees, that would be 30 degrees. Our reference angle in this problem is a 30-degree angle. For letter B, we're going to do the same thing, but we're going to do this with a different angle. We'll go 300 degrees on this one. So again, we want to go through and create our X and Y axis. I want to draw a 300-degree angle in standard position. It is a positive angle, so I'd want to go around until I got to 300 degrees. Down to the bottom here, that's where 270 is. All the way around is 360. So a 300-degree angle would be between those. It would be somewhere about right here. That is approximately where a 300-degree angle is. So there's our 300-degree angle. And the angle in between that terminal side and the nearest x-axis, which in this case would be the right side here, this angle here, that is our reference angle. 300 degrees is how far we went. All the way around back to here would be 360 degrees. That would be a full circle. So if we subtract those values, we have a reference angle of 60 degrees this time. Sometimes as you go through and do these problems, instead of doing these with degree measure, you're going to be asked to do them in radian measure. So for this last example, we'll do one in radians. Let's do 5 pi over 4. So in order for us to go through and graph this, you either need to know where 5 pi over 4 is, or you may want to possibly convert that into degree measure. That would also work. So I'm going to start and put my initial side in on the positive x-axis. This angle is positive, so I'm going to be going around counterclockwise. I just need to know how far 5 pi over 4 is. When you do that conversion, if you're going to convert it into degrees, just to make this a little bit easier, if you're more comfortable with degrees, that would be an okay thing to do. You would multiply by 180 degrees over pi. The pi's would cancel, and what you would end up with is a 225 degree angle once you've calculated that. 225 degrees, well, halfway around is 180, so it's past that. 3/4 of the way around is 270, so it's not quite that far. So our angle, which is 5 pi over 4, that is going to be down here in the third quadrant. Our angle that we have to calculate for the reference angle is the angle between that side and then the closest x-axis. So our reference angle this time is going to be this angle right here. And what we'd want to do is subtract 5 pi over 4 and whatever this value is here in radians. All the way around the circle in radians is 2 pi. Halfway around the circle would be half of that, so it would be pi. So you'd want to subtract 5 pi over 4 and pi. If you did that, you would end up with pi over 4 for our reference angle for our final answer on that. There is an easier way to get your reference angle. You don't even need to do the subtraction. The reference angle is always going to be pi over a number. And that number that's on the bottom part of the fraction is always going to be the same as the bottom on the original. So without even doing any calculating on this, if you have 5 pi over 4 as your angle, the reference angle is going to be pi over that bottom number, so pi over 4. If you had an angle here of like 7 pi over 6, then the reference angle would be pi over 6, that same denominator again. If your reference angle is 2 pi over 3, if your angle is 2 pi over 3, then your reference angle would be pi over 3. So you don't actually have to do the subtraction to figure out your reference angle for angles that are in radian measure. You certainly can, but the answer will always be pi divided by the original denominator.